This is what it feels like to write nav movement code in Godot. Here's a few tips on improving it. For this video, we're going to start with this awful movement code and extend it to be not so trash. So in our process function, we first check whether we have our upwards input pressed, and then move our parent node up by vector2.up multiplied by speed multiplied by delta, delta being how long each frame takes to calculate, so frame rate drops don't change our speed. We do the same in an else if statement to check the down movement, but instead move it by vector2.down multiplied by speed multiplied by delta. So let's start modifying our code. We're getting the parent node every frame. This is poorly performing code. Grab a reference to the parent in the ready function and store it. Then we can instead reference that. This will improve performance by a smidge. In a similar vein, let's turn our speed into either a variable or a constant. In this case, I'm going to turn it into a constant and call it player base speed. This means we can change one value and have it affect any lines of code that we reference our speed in. In a similar vein, let's move our movement code out of process into its own procedure. This works the same, but is already much tidier. Now let's make some changes that greatly improve it further. We have duplicate code for moving up and down. This is bad practice. Instead, let's create a float for player input and then change our movement code so that we go in the positive direction, multiplied by our new player input variable. Our positive direction is down, as if we increase our Y position, our plane goes downwards. Now let's create a new function that returns the input direction. Set our player input variable to be the return value of this function. Within this function, we want to get the strength of our positive input, so the input going down and increasing the Y position. So get action strength of the down input, then minus the opposite input from that, so minus the up input. You see, it works the same, but the code is much nicer to look at. However, there is one difference between our original code and this new version. Our input now has variable speed if we use a controller's analog stick, so we can either keep that, or we can use math.sign within our vertical movement function. This returns either -1, 0, or 1, depending on the player input, which is the same as it was before. Godot pros may be shouting at their screen right now with one extra change we can make for clarity. Instead of doing our positive get action strength minus our negative get action strength, we can instead use a built-in function, input.getAxis, and pass through our negative and positive inputs in that order. This does the same, but has more clarity. So our little plain example is perfect, but there's more we can learn about user input. Let's say we're making a platformer, but before that, if you're liking this video so far, then click subscribe, as there's more Godot videos coming soon. So back to a platformer. It's a lot more complicated code, with acceleration and deceleration. However, in this example code, we have already grabbed all references we need inside the ready function. We've already set many values as constants or variables. We've even separated out different procedures for clarity. So we're sitting pretty. However, improvements can still be made. Our actual input code is a mess. We're doing an if statement with a set of code for left movement, then for right movement, and then unique code for deceleration. This is a real mess to read and a real mess to modify. So let's create a function that returns out button inputs for left and right. Use getAxis. We are treating this platformer like an old school game without analog sticks. So let's return math.sign. For each direction, we first check if we're running in the wrong direction, which we can do by checking whether math.sign equals the same as our input direction. We can then multiply our deceleration by the correct direction. Same for the acceleration code, multiply it by our direction. Rather than checking our top speed by an if statement, we can use math.clamp to keep our value within a set range. Finally, in our deceleration code, we change the value and check whether we flipped signs. This is the only area where we'll need to majorly change it, to instead store the sign before the change and then check against that. And as easy as that, we went from unruly code to code that is much easier to read. Note that it still actually plays the same, it just is completely different code for the same thing. If we need to make changes in the future, this will be much easier to modify, before and after. Overall, going from basic movement code to difficult movement code. Clarity when programming helps a lot. Let me know of your own tricks and tips in the comments. Like and subscribe, and check out my website for source code.